Hey, everyone, get ready to hear something truly mind-blowing. The US Air Force has finally confirmed the existence of the secret SR-72 Darkstar. And this isn't just old tales. Since 2007, there have only been rumors about it. And now we have real information. Forget everything you knew about speed. Because this hypersonic monster is about to turn the sky upside down. Do you want to know how and when this will happen? The most interesting part is to come. In 2007, the world learned about a new ambitious project by Lockheed Martin, the creation of a supersonic aircraft codenamed SR-72. SR-72 development information remains strictly classified. However, some details have already leaked into the public domain. The SR-70 Blackbird, which focused on reconnaissance missions, the SR-72 will combine the functions of a reconnaissance aircraft and a fighter, boosting its combat capabilities. Will combine the functions of a reconnaissance aircraft and a fighter, significantly expanding its combat capabilities. This will make the aircraft much more versatile and in demand. As for the armament, Lockheed Martin stated that the SR-72 will be able to deploy hypersonic missiles. The development of hypersonic weapons in the US is in full swing, and the use of such missiles on board the SR-72 will become possible right after their successful testing. The Pentagon is interested in acquiring this machine, which will be capable of reaching an incredible speed of over 6 Mach, or more than 3,900 miles per hour, around 6,400 kilometers per hour. This would make it one of the fastest aircraft in history, invisible to radar and other detection systems. For comparison, the SR-70, the Blackbird reached a modest speed of 2,200 to 2,700 miles per hour. The new speed threshold that the Darkstar needs to overcome creates additional challenges, which I will discuss next. At such an enormous speed of 6 Mach, the aircraft's fuselage will experience intense heating, reaching temperatures above 482 degrees in Fahrenheit. According to estimates by independent experts, the inner surface of the cockpit glazing could heat up to 248 degrees Fahrenheit. Theoretically, the cockpit could be equipped with a cooling system to ensure the crew's safety. However, ejecting at such speeds can pose serious risks. However, even when addressing the overheating issues, there are still significant challenges in ensuring the aircraft's stealth. The radar-absorbing coatings used to reduce visibility on radars start to melt at much lower temperatures, such as 100 degrees Celsius. Moreover, a heavily heated aircraft becomes an easy target for infrared sensors. Even if we manage to tackle these problems, there will still be another difficulty. At hypersonic speed, the aircraft will create such a dense airstream that its wake will become visible on regular radars. The design of the fuselage and wings also requires a special approach. Traditional aluminum alloys lose their strength at such temperatures. So for the SR-72 Darkstar, we'll have to create composite materials that include polymers, ceramics, and metals. Standard turbojet engines have speed limitations due to the characteristics of how the fans operate. Even for the SR-70, one of the other hypersonic projects of the US Air Force, the engine developer Pratt & Whitney had to create a special J58 engine. Known as a turbojet, it's a hybrid of turbojet and ramjet engines, where adjustable cones in the air intake slow down the airflow before it reaches the combustion chamber. Darkstar will need an even more versatile hybrid engine, capable of functioning in both subsonic modes for takeoff and landing, as well as at cruising speed, over 5 Mach. The SR-72. 2 engines will be installed. Turbojet and turbofan engines are suitable for providing power during takeoff and landing phases, but they cannot maintain hypersonic speeds. Jet engines that operate at hypersonic speeds are unsuitable for takeoff and landing. SR-72 uses a gas turbine. Needs an engine that can efficiently handle both tasks. For this, the aircraft will use a gas turbine engine until it reaches speed 3 Mach. After that, subsequently, control will switch to a dual-mode scramjet engine. To minimize drag, the aircraft is designed with a single nozzle for both types of engines. Lockheed Martin, together with Aerojet Rocketdyne, is working on creating a turbine power plant with a combined cycle that will provide cruising speed. 6 Mach, which is twice the speed of the SR-71. Large-scale ground tests of the combined cycle turbine power plant system are being conducted by integrating a standard turbine engine with a dual-mode scramjet engine featuring symmetrical inlets and nozzles. According to data from the Air Force Technology Portal, the SR-72 will be a hypersonic reconnaissance aircraft equipped with the latest technologies for carrying out missions at distances comparable to those covered by the SR-71. The aircraft will be able to strike targets on any continent within 1 hour. If it is equipped with hypersonic missiles, such as the high-speed strike weapon produced by Lockheed Martin, high speed of SR-72 will give it the ability to quickly bypass enemy air defense zones, at least according to the theory. The long-term plans of the U.S. Air Force include supporting the development of the SR-72, which will most likely be adapted for combat operations. Hypersonic SR-702. In all respects, it outperforms its predecessors, such as the experimental models X-43 and Waiver Rider, which were primarily developed for testing scramjet engines. SR-72, a multi-role aircraft, uses composite, is being developed as a multi-role aircraft, made using modern materials, including carbon-carbon composites. These materials show greater resistance to high temperatures compared to titanium coatings used on the SR-71 to dissipate heat during high-speed flights. Overheating from air friction will be the fight against overheating, which occurs due to air friction at a speed of about 6 Mach. I mentioned earlier that such a problem exists. There are 2 possible ways to solve this problem. The first involves using cold structures, for example, similar to those used in space shuttles. The second option involves the use of heat-resistant materials, such as titanium. It's also designed with a focus on high speed, low observability, and versatility of use. If the experimental version of the aircraft is put into operation, it will most likely be equipped with modern aviation systems and possibly artificial intelligence for autonomous operation. Functions that previous hypersonic machines did not have. Stealth may fail for the SR-72 due to heat-resistant limits of radar-absorbing materials and its high thermal signature. Since materials that absorb radio waves may not withstand extreme temperatures. Moreover, the aircraft's high thermal signature significantly reduces the effectiveness of most stealth reduction methods, like its predecessors, for example, the SR-71. The aircraft can leave traces that can be detected by radars. Nevertheless, due to its impressive speeds and the ability to quickly exit the strike zone, outpacing most traditional sub-hypersonic missiles, these potential drawbacks seem more hypothetical. Like its predecessor, the SR-72 is capable of operating on more exotic types of fuel, such as JP-7. However, it is assumed that Lockheed is considering using standard fuel to simplify logistics and reduce operating costs. JP-7 is jet fuel for the SR-71. It was designed for fast, high-altitude flights. Blackbird. This fuel was developed with specific requirements in mind for high-speed flights at high altitudes. JP-7 fuel had several unique properties. Among these, the high flash point significantly stood out, and therefore making it considerably less prone to ignition at low temperatures. This characteristic played a key role in ensuring the safety of the aircraft during high-speed flights. The heat resistance of the fuel used in the SR-71 was crucial for the operation of the engines and aviation electronics, as it also served as a coolant. The unique formula of JP-7 made a significant contribution to ensuring the outstanding performance characteristics of the SR-71. There has been a lot of discussion and news surrounding the development of the SR-72. In 2017, Lockheed Martin announced that the hypersonic engine for the aircraft was fully ready for operation. This was preceded by a series of ground tests, which are believed to have started back in 2013. The first flight of the new hypersonic strike aircraft SR-72 Darkstar is scheduled for 2025. The goal is to bring the twin-engine version into service by 2030. This project takes modern aerospace technology to a new level, and the first test flights are expected to be a key step in the journey from concept to a real aircraft. Even though the Darkstar plane from the movie Top Gun Maverick does not exist in reality, its prototype is undoubtedly the SR-72. This project is still surrounded by secrecy, so I had to collect information about it literally bit by bit. SR-71 was before SR-72. SR-72 is cooler. Darkstar, the SR-71 hypersonic reconnaissance aircraft. Blackbird, and you'll be able to see for yourself just how much cooler the new aircraft is compared to the previous one. In the mid-1960s, reports of strange sky events emerged. Sudden thunder erupted and faded. They began reaching out to the authorities with reports of unusual phenomena in the sky. On clear days, a sudden thunder would erupt, quickly fading away and disappearing. Time passed, but the mysterious sounds continued to disturb people. Finally, on July 10, 1967, when the number of complaints had significantly increased, the U.S. Air Force released an official statement. It stated that the cause of these sounds was the flights of the new supersonic reconnaissance aircraft Lockheed SR-71. This story continued with several dozen lawsuits from residents who demanded compensation for the damage caused by military flights. By court order, the military paid compensation of $36,000. However, this amount was insignificant compared to the operating costs of the SR-71. One of the fastest and most expensive military aircraft of its time, SR-71 flew. Known among the military as the Blackbird due to its appearance, took place on December 22, 1964. Year. This aircraft was designed for use by the U.S. Air Force, which at that time had no counterparts. The new generation of supersonic reconnaissance aircraft, like the A-12, which was in service with the CIA, SR-70, modified. One was a modification of two other models, A-12, F-12, combining the functions of an interceptor and a reconnaissance aircraft. The takeoff weight of the SR-70 weighed 172,000 pounds, 78 tons, and its main advantage was a maximum speed of 2,193.17 miles per hour. It remains unmatched to this day. SR-71 cools with JP-7. It was a specially designed fuel JP-7 for supersonic aviation in the US. It continuously circulated from the fuel tanks through the aircraft's skin to the engines, providing constant cooling for the fuselage. And at the same time, it heated up to 608 degrees Fahrenheit. Takeoff. SR-70 took about 4,200 knots feet, after which it lifted off the ground at a speed of 248 miles per hour. 2.5 minutes after takeoff, at an altitude of 4.7 miles, and a speed of 422.5 miles per hour. Refueling was taking place from the KC-135K air tanker. After refueling, the pilot switched control to autopilot, allowing the aircraft to gain altitude at a speed of 4.7 miles per hour, 534 miles per hour. At an altitude of 15 miles and a speed of 3 Mach, control would once again switch back to the pilots. SR-71 primary reconnaissance area included Vietnam, North Korea, the Middle East, Cuba, and despite warnings from the Air Force Command, the Soviet Union in the Kola Peninsula region. SR-71 equipment used several aerial cameras, the side-looking radar system and thermal images. The panoramic and aerial camera was located in the nose of the aircraft. SR-70 surveyed to survey 59,846 SQMI in 1 hour at 15 miles, to survey an area of 59,846 square miles. Before landing, the pilots activated the autopilot. During descent, the aircraft's speed decreased to 466 miles per hour, and during the approach for landing, it dropped to 280 miles per hour. Touchdown on the runway occurred at a speed of 168 miles per hour. After touchdown, the braking parachute deployed. traveled 3609 feet. Then the parachute, the aircraft continued to decelerate using the main brakes. And the 1980s marked the beginning of the process of retiring the SR-71, one of the aircraft in the U.S. Air Force. The reasons for this were numerous. Frequent accidents, high operating costs, the scarcity and expense of spare parts, as well as vulnerability to Soviet air defense systems. In the fall of 1989, it was decided to retire the SR-71. Opponents insisted that there was no worthy replacement. From service, opponents said no worthy replacement existed. Spy satellites were not effective replacements, emphasizing that the spy satellites were costlier and less efficient than Blackbirds. Some aircraft went to museums, others to NASA and Pentagon. Then the Blackbirds. Most of the aircraft were transferred to museums. Several remained at bases in an inactive state, and some examples were transferred to NASA and the Pentagon. Darkstar may fail, but aids hypersonic dreams. Proposal. If Darkstar turns out to be unsuccessful, the knowledge gained could contribute to realizing human dreams of hypersonic flights. And now, friends, I want to make you an interesting proposal. You have a unique opportunity. Join our team. If you have video editing skills, you can voice videos in Russian, English, and other languages, or write interesting scripts. We would be happy to work with you. Message our Telegram bot. Link is in the description. That's all for today. Thank you for watching.